Hello folks, this video is going over your similar triangles study guide for your test. Hopefully you've had a chance to kind of do some of these questions on your own and get an idea of your understanding. So we're going to go through each one and I'll explain the best problem solving strategy to solve each one. So number one says, if one triangle has side lengths of 8, 12, and 18, another has corresponding side lengths of 20, 30, and x, what is the value of x? Now, you don't have to, but if you want to, you could go ahead and draw triangles that represent these scenarios. So like 8, 12, and 18. And a second triangle. It's okay if it's not, exactly representative of these numbers. Now, the order that you label the pictures, because it's respectively, needs to be in the same spot. So if you labeled this triangle 8, 12, and 18, you need to label the next triangle in those same spot, in that same order. So 20, 30, and x. So the question is, what is the value of x? The tricky part about this question is that they actually give us more information than what we need. If I'm going to solve for x, we can set up a proportion of the little triangle over the big triangle. And in doing so, it doesn't matter, there are going to be two values that you don't need, but you definitely want to make sure that you choose whatever side corresponds with x, since that's what we're solving for, right? So you may want to choose 18 from the little triangle. It corresponds to x of the big triangle. And if these are going to be proportional to each other, then I need to choose another little triangle measurement. It doesn't matter which one, I'll just choose 8. 8 corresponds with 20. And the other sides, 12 and 30, are just extra information. You don't need that. You only need two ratios. Then from here, we can cross multiply to solve. So if I cross multiply, I'm going to end up with 8x is equal to 18 times 20 is 360. Oops. 360. And then if I divide both sides by 8, 360 divided by 8 gives me a value of x, which is 45. And if you wanted to check your answer, you could plug that back into the fraction and simplify those fractions and make sure you got the same decimal. Number 2 says verify that triangle ABC is similar to triangle ADE. Okay, so if I'm going to verify, that means they are similar already and they need me to prove how I know. So a few things. I need to choose a postulate. So at the top of the paper, let's go ahead and write our three postulates. When I prove or verify triangles are similar, I'm either going to use SSS, SAS, or AA. So given information in this picture right now, if I just focus on the little triangle, notice I only have two measurements, right? I have the left side and I have the right side. And the interesting part about those two measurements is that they don't correspond to 4 and 5.6. They correspond to the entire left side and entire right side of the big triangle. So this big blue triangle, its left side length is going to be 4 plus 5, which is 9. And the entire right-hand side is going to be 7 plus 5.6, which is 12.6. So let's look at what I have. I have two pairs of sides, and that's it. So I can't use SSS because I don't know anything about the bottom sides. And as far as AA goes, I don't off the bat see anything about angles. However, we do know that angle A, this angle here at the top, notice it is shared by both the red and the blue triangle. So therefore we can say angle A is congruent to angle A because of the reflexive property, right? Anytime something is congruent to itself, it's by the reflexive property. So it looks like we might use SAS because we have two sides and the angle in between. But before we can claim that, we need to, again, verify. So I need to check the math with the proportions. So if I put the little triangle over the big triangle, I'm going to make a proportion. One of my little triangle measurements is 5. Again, 5 is the left side of the little triangle. it corresponds with the left side of the big blue triangle, which we established earlier is 9. So 5 corresponds with 9. And I need to try to verify if that equals the other little triangle measurement is 7. It corresponds with 12.6, right? The entire right side. So you could do two things. You can go ahead and cross multiply if you wanted, or you can simply just simplify these fractions. 5 divided by 9 in your calculator, you're going to get 0.55 repeating. And if you divide 7 divided by 12.6, you're also going to get 0.55 repeating. If you get the same decimals, then that means they're proportional. So we can claim triangle ABC is similar to triangle ADE. I'm just repeating the question essentially, except I'm going to say by SAS. We proved two sides were proportional and we showed the angle was congruent. Number 3 says find AD. Find AD. Now you can't really see it really well on my sheet. I don't know if you can on yours, but these little marks here are showing that these lines are parallel to each other. So if those lines are parallel to each other, I know some information. I know that, so actually before I jump to that, if I'm looking for AD, let me put an X value where that is, since that's what I'm trying to solve for. So these triangles look very similar, pun kind of intended, to number 2, except it's not asking me to verify the triangles are similar, it's asking me to solve. So in order for me to solve, I do need to prove that they're similar, which if I have these parallel lines, then I know my corresponding angles here and here are going to be congruent. And by the reflexive property, I know angle B is congruent to itself as well. So I can go ahead and claim, okay, I know the triangles are similar by AA. And then if I'm going to solve for AD, I'm going to set up a proportion. So again, we're going to set up, just to keep things consistent, I do little triangle over big triangle. So let me outline the little triangle in black. Okay, one of the little triangle measurements is 5. It is the left side of the little triangle. So actually, I'm going to do the other one. You'll see why here in a second. I want to make a point first. So let me choose the other side. Let me choose 7. So 7 is the bottom side of the little triangle. It corresponds with the bottom side of the big triangle, which is 7 plus 3, which is 10. Okay, so 7 corresponds to 10. This ratio is going to equal, the other little triangle measurement is 5. It's the left side, and it corresponds with the entire left side of the big triangle. Now, the mistake people make is calling this side 5x, but that is so far from the truth. Think about what you did to find 10. Didn't all we do was just add 7 plus 3? So if I want to find the left side of the big triangle, as weird as it is, because it's not actually going to be a number, we're going to add 5 plus x, even though we don't know what x is. So it's going to be 5 plus x. And then if I'm trying to solve for AD, that means I just want to solve for x. So I'm going to go ahead and treat this, even though there is a variable here and kind of a, this is called a binomial, it has 2 parts, I'm going to cross multiply. So if I cross multiply, I'm going to get 10 times 5 is equal to 7 times 5 plus x. And 5 plus x needs to go in parentheses. And if you think back to your algebra days, 10 times 5 is 50. We're going to distribute this 7 to the 5 and to the x. So 7 times 5 is 35 plus 7x. Okay, and then if I'm continuing to try to get x alone, I'm going to subtract 35 from both sides. So 50 minus 35 is 15 is equal to 7x. And then if I divide both sides by 7, I'm going to get x is equal to 15 over 7. Now, if you divide 15 over 7 in your calculator, you're going to get approximately 2.14. I personally prefer you leaving your answer as the fraction, as opposed to rounding it to the decimal. So I'd ask you to leave that as a fraction. If you get to the decimal, All you need to do to go back to the fraction is hit math enter in your calculator, and it'll convert it back to the fraction for you. Number 4, explain why the triangles are similar, and then find BC. Okay, well, to explain why triangles are similar, again, that means I'm going to use one of my similarity postulates written up at the top of my page. So if I look at information, I have some information about the sides, but guys, always try angle, angle first. That is the easiest one. So if you can prove by angle, angle, that's going to be the easiest route. So first of all, I'm given some information. Notice I have a couple of angle measures already marked. So then I can say, oh, mine's very faint. I hope yours isn't this faint. This is angle A, angle B, angle C. This here is E, and this point here is D. Okay, so I know I'm given, because they're marked on the triangle already, that angle BED is congruent to angle C. Now you could call angle C angle ACB, but notice how angle C doesn't share any other angle, so you don't have to use 3 letters there. And that's just given information. It's already marked on the picture. We also know by the reflexive property, since the little red triangle is kind of sitting inside of the big triangle, that we can go ahead and say angle B is congruent to itself, angle B. Hopefully you remember, anytime something is congruent to itself, it's by the reflexive property. So I've shown that triangle ABC is similar to triangle DBE by angle, angle. And that's all I need. So that's step 1. And then step 2 is to find BC. So again, let me look at my picture, and if I don't have a variable there, let me put one. So BC is this entire length here. So I'm going to put an X there. So it's not as simple. I know this is 20, but I just need to figure out what this little length is, and then I can figure out what X is. Well, let's set up a proportion, right? That's what we've been doing with all this other stuff. So if I set up a proportion of little triangle to big triangle, one of my little triangle measurements is 26. That's the bottom side. So 26 on the bottom must correspond to 34 on the bottom of the big triangle. My other little triangle measurement is 20. And it is the right side of the little triangle, so it corresponds with the right side of the big triangle. Well, what is the right side of the big triangle? The entire side we just labeled as X. So actually, I don't even need this little green area that I drew earlier, because all I'm looking for is X, which fits perfectly in the proportion. And then from here, if I want to solve for X, I'm going to cross multiply. So then I'm going to get 26x is equal to 34 times 20 is going to be 680. And then if I divide both sides by 26, I end up with x. Let me get my blue color back. X is equal to, if I reduce 680 over 26, I'm actually going to end up with 340 over 13. Again, if you divide 340 over 13 in your calculator, you will get approximately 26.15, but I would prefer you just leave your answer as a fraction, unless the directions say round to the nearest tenth or whatever. Okay, number 5 should be the easiest question on the test. There's one almost just like it. I'm asking you to list the pairs of congruent angles and the pairs of proportional corresponding side lengths. Okay, so this one's pretty simple. You just have to figure out what corresponds to each other. So I'm going to say angle, and there's kind of a method to this. Again, mine's kind of dark, so let me highlight it. X has 2 congruent tick marks or arcs, Z has 1, T has 1, and R has 2. So I'm going to use those to my advantage. I'm going to go ahead and say that angle Z, it has 1 arc mark, therefore it is congruent to angle T. 2 arc marks is going to be angle X, which is congruent to angle R. And lastly, that means angle Y is congruent to angle S. So I know in a similar triangle, my three angles are congruent. When I list the pairs of corresponding side lengths, you just need to pick which sides correspond to one another. So again, there's kind of a method to this. Just pick any side of, you can do little triangle over big, or it doesn't really matter. I'm just going to do the triangle on the left over the triangle on the right. So in doing so, let's pick the biggest side length. So in the triangle on the left, the biggest side length is 16. Now, I want the names of, so it says list the pairs. So I want the names of the sides, not the numbers. And I'll be sure to word that a little bit better on your test. So 16 is actually represented by XZ, side XZ. It's the biggest side, so it corresponds to the biggest side of this triangle, which is TR. So XZ over TR should equal, give me another proportion. Let's jump to the smallest side, which is XY. XY being the smallest side should correspond to this smallest side, which is 6, which is RS. And that ratio is going to correspond to the middle length side, which is YZ, over the middle length side here is TS. So those are the three pairs of congruent sides and the three pairs of proportional side lengths. Number 6, a flagpole is standing next to a 60-foot high building. The flagpole has a 10-foot shadow, while the building has a 25-foot shadow. How tall is the flagpole? Now, we haven't done a problem like this before, but think about what section we're in. We're dealing with similar triangles. So let me draw these scenarios. Okay, the first one, it says I've got a flagpole. So there's my flagpole, there's my flag. Beautiful. It says the flagpole has a 10-foot shadow. Shadows are on the ground, right? So that must mean this is going to be the 10-foot shadow of the flagpole. It's standing next to a 60-foot high building. So let me draw this here. There's my building. It's 60 feet tall. And the building's shadow, so again, shadows are on the ground, is 25 feet. So the question is, how tall is the flagpole? So let me put an X there since that's what I'm trying to find. Well, guys, these make right triangles. In particular, if they're the same angles of depression from the sun, I know that these triangles must be similar. And if these triangles must be similar, then I could just set up a proportion. So let's do that. Let's do the little triangle to the big triangle proportion. So the little triangle, I've got my 10-foot shadow. Actually, you don't even have to do little and big. You could call these like by what they are in real life. So you can put, let's do this. Let's do object is being compared to its shadow. So the first object is the flagpole, which is X. The shadow of the flagpole is 10. That ratio should equal the second object, which is the building, which is 60 feet, over its shadow, which is 25 feet. And this isn't the only way to set up the proportion. You could have easily done little triangle to big triangle and you would still get the same answer. Okay, and from here you'll go ahead and cross multiply. So X times 25 will be 25X. 10 times 60 is 600. 600. And then if I divide both sides by 25, I end up with X is equal to 24 feet. So the flagpole must be 24 feet tall. Number 7, find the distance between Riverside and Milton if they are 12 centimeters apart on a map with a scale of 4 centimeters to 21 kilometers. So let's think about this for a second. Again, word problems seem a little bit confusing, but all we're dealing with is proportions. So you need to figure out what are you comparing, right? We do ratios and proportions all the time, like wins to losses, boys to girls. So what exactly are we comparing? We're comparing the scale that's on a map to real life. So let that be your ratio. the scale that's on the map to real life. So one of the scales that's on the map is 4 centimeters. All right, 4 centimeters. Now, it's saying they're 12 centimeters apart on the map. 12 centimeters apart on the map. And in real life, if it's, so notice centimeters goes with centimeters. So that means that the 4 centimeters on the map compares to the 21 kilometers in real life. Okay, so 4 centimeters on the map compares to 21 kilometers in real life. This ratio should equal the other ratio, and that's where I shouldn't have underlined this yet. Let me do a different color. So that's where this part comes in. The 12 centimeters apart on the map is the map scale, 12 centimeters. And the question is, how far apart are they really in real life? So that's where X is going to go. Okay, so the scale is 4 to 21. And in real life, we're trying to figure out if the scale is 12, what is the true distance? So the hardest part is setting it up. But again, if you actually write out in words what you're comparing, it helps you set it up. And then if we cross multiply, we get 4 times x, which is 4x, is equal to 21 times 12 is 252. And then if you divide both sides by 4, you end up with x is equal to 63 kilometers in real life. Moving on to number 8. Do I not have a number 8? Nope, look at that. You got one back. I jumped straight to number 9. Okay, it says determine whether the polygons are similar, and if so, write by which postulate in a similarity statement. So again, at the top of our paper, let's write the 3 postulates, SSS, SAS, and AA. And I hope yours isn't this dark, but mine was when I scanned it in. So I've got A, D, B, E, C, and I know that these are parallel to each other. Okay, and that's all that I know. So notice I'm given no side lengths. If I'm given no side lengths, then my only shot at this is trying to use angle. So what do I know about angles? Well, hopefully the first thing that you do is say, okay, I know angle B is congruent to angle B. It's shared by the little triangle and the big triangle because of the reflexive property. The other bit of information that we know is if I were to extend these parallel lines beyond the triangle and drop down a transversal, I also know that these two angles in green are congruent to each other. Does anybody remember why? It starts with a C. So let's actually name those angles. The first one will be angle BDE, that's this angle here, BDE, is going to be congruent to angle BAC. And with those two parallel lines in a transversal, it's because they are corresponding to each other. Notice they're in like the same spots. So if they're corresponding, well, look what you just proved. You proved 2 pairs of angles are congruent. Therefore, we can conclude triangle DBE must be similar to triangle ABC by AA, angle postulate. Okay, number 10, a model house is 12 centimeters wide. If it was built with a scale of 3 centimeters to 4 meters, then how wide is the real house? So this one's kind of like the other problem, so let's give it another go. Again, what are we comparing? We are comparing a model house to real life. And it might also help to put the units of measure. What is the model house being measured in? What units? It's being measured in centimeters. So the model measurements are in centimeters. In real life, notice over here, that's where the scale comes into play. Centimeters is going to be the model. So that means in real life, we're referring to meters. So if we're trying to set up the proportion that way, the model house is 12 centimeters wide. The question is, how wide is the real house? So that's the model compared to the real house. I don't know what that is. That's why I'm calling that x. That ratio is going to equal the scale. So the scale of the model is this right here. That's going to be 3 centimeters to 4 meters. And then if I cross multiply, I can solve. So I'm going to do 12 times 4 and x times 3. So 12 times 4 is 48. X times 3 is 3x. And then if I divide both sides by 3, 48 divided by 3 is going to give me a value of 16 meters. So in real life, the house is 16 meters wide. Okay, the last 4, we did something very similar to this yesterday, comparing these triangles to figure out if they are similar, and if so, which postulate, and if not, why not. So it says for each triangle pairs below, determine if they are similar, show your work. Okay, you have to prove if the sides are proportional. Don't just take it for granted. And if so, write a similarity statement. Verify with a similarity postulate. Again, the postulates are SAS, SSS, and AA. So for number 11, let's look at what information I'm given. I'm given 2 pairs of sides. So I know I have an S and an S. And I know that these angles in the middle are congruent to each other because they're vertical. So my shot at this is going to be SAS, but I don't know for sure. I know the angles are congruent, so that angle's good, but I need to check, are the sides proportional? So let me set up a proportion. If I set up a proportion, I'm going to compare the sides. So let me do, the triangle on the right to the left. Or you could do triangle left to right. It doesn't really look like one is bigger than the other. I mean, I guess this one would be the little triangle, but it doesn't matter. Okay, so I'm going to compare 16. 16 corresponds with 39. And I want to know, does that equal 16, the other measurement, interesting, over 40? Well, you could plug these in your calculator if you want. 16 over 39 is going to be about 0.41. 16 over 40 is going to be 0.4, but hopefully logic tells you that these two fractions don't equal each other. So if they don't equal each other, even though SAS is tempting, you can't use it because the sides are not proportional. So don't even fill out this nonsense. You're just going to put not similar. Okay, for number 12, look at what we have. We are given 61 degrees and 61 degrees. So we know we have 1 pair of congruent angles. And we know that the angles in the middle here are vertical angles. So that's all we need. Angles are congruent. We know them by measure and by vertical angle definition. So then we can say triangle THS is similar to triangle. Remember, your names have to correspond. So since T is 61 degrees, it must correspond to G, and then H corresponds with H, and then S corresponds with F by angle AA. Number 13, with these 2 triangles, look at the information you're given. The only thing that I know is I have 2 pairs of sides, and I have the angle between them, right? Side, side, angle in between, side, side, angle in between. So we know the angles are congruent. They're both 76, so that's good. But now you have to check and see, are the sides proportional? So to do that, you're going to literally set up a proportion. So if you do the little triangle over the big triangle, or the triangle on top over the triangle over the bottom, however you want to do it. So let me just pick any measurement. Let me pick 9. 9 is the smaller number in this triangle, so I know it's got to correspond with the smaller number in this triangle, which is 21. And I want to know, does 9 over 21 equal the same ratio as the other little triangle measurement is 18, and therefore it must correspond to 42. So once you set this up in your calculator, you can divide 9 over 21, which is 0.42, and it'll round up to about 0.429. And then you'll also divide 18 over 42, and you're actually going to get the same decimal, about 4.29. So if that happens, that means they are proportional. So then we can say triangle UTHS WV is similar to triangle. Now notice U is the 76-degree angle, so it must correspond to F. W is across from the biggest side, so it must correspond to across from the biggest side in this triangle is H, and then G. And then you just used SAS. The last one, notice I'm given no information about about angles. The only thing I'm given are the 3 pairs of sides. So could it be SSS? I don't know. You have to prove it. So again, let's set up little triangle. Let's do big over little, just to show you that it really doesn't matter which way you order it as long as you keep them organized. Okay, so give me one of the big triangle side lengths. Let's just go with the smallest for now. So the smallest side length in the big triangle is 48. So it must correspond with the smallest in the little one, which is 8. I want to know, does that ratio equal, the biggest side length is 84 in the big triangle, so it must correspond to 14. And does that ratio equal the third, which has to be 72 over 12? And in your calculator, you will divide those 3. 48 divided by 8, 84 divided by 14, and 72 divided by 12. And you're actually going to get that all of those equal 6. So if they all equal the same number, they are proportional. So we can go ahead and claim that triangle ABC is similar to triangle HGF by SSS. So the key is to list out what information you have, and anytime that you want to use sides, you have to prove that the sides are proportional to each other. The most crucial information, it's going to be one of the first couple questions on your test, is the angles of similar triangles. The angles of similar triangles must be congruent. They have to be congruent, but the sides must be proportional. Your whole test is based off of these 2 facts right here. Okay? Best of luck to you. Make sure you study. If you have any questions, shoot me an email and I'll be ready to assist you.